like we were live.
Yep.
All right. Straight to the quiz.
Yep.
I think question 3 is true.
I'm not there yet. Oh. My Excel almost crashed too, so that was awesome.
That's super cool. I love that.
Jeez, how big is this quantitative descriptive file?
Like 10 megabytes.
Jeez.
3, I'm thinking it's true as well. You said true, right?
I did say true.
Okay.
What?
It's B and C, right? For 4. Sorry.
I think so. I mean, the sample means are all positive for the F distribution. Let's see. Yeah, no, so you're right. The requirements for an ANOVA are that the data is normally distributed and that the variances are equal. They're trying to trick us because the values of the F distribution are never negative.
That's silly.
To check if a group construct a QQ plot. The largest variance is less than 4 times the smallest variance.
I think so, yeah.
Let me find it in the book and just make sure that I'm remembering that right.
Have you guys been using SPSS?
I use Excel.
Yeah, I haven't.
Me
used
too.
it.
I've never even used the SPSS.
It's supposed to be a better program for like super in-depth statistics stuff.
Who cares about that?
Yeah, if the largest variance is at least 4 times as big as the smallest variance, we conclude that the population variances are not equal. If the largest variance is not 4 times as big as the smallest variance, we conclude that the population variances are close enough that we can assume that they're all equal.
Okay.
Where's this at?
So that's B then.
It's in the book. It's for question 6 in section 3.3 at the bottom of the Excel instructions.
So 7's just 6, right?
I think so.
So you would just double pairs.
There's 3 samples, there's 3 pairs. So 4 samples would be
6.
6. Do they say that in the book that you just double it, or are we just guessing that? I didn't remember reading that part.
I think I remembered reading it somewhere, but I'm not positive. Let me double check. Um,
Yeah, I think you're right.
where did I see it?
At the very top, analysis of a variance, or right above that, it says we could conduct separate t-tests for the possible pairs of a group. If we would do that, we'd need to conduct separate t-tests for 1 and 2, 1 and 3, and 2 and 3. So if we had to do that for 4, it'd be 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2
Yeah.
and 4. Is that only 5? No, it is 6.
Cool.
So when we pull this data out, do we have to just select the numbers for A and put that in one column, the numbers for B, and et cetera?
That's what I did.
Okay. That's kind of annoying.
Yeah.
So this would be. So we'd use the quantitative descriptive method, right?
We go into the quantitative inference one,
Oh.
and then we go under ANOVA test.
Wait, so how are you setting it up again?
All right, so they just list like 20 instances of A with the numbers, and then it goes to B. So you just have to like select and copy out those numbers for A and paste them in variable 1, and then do the same for B.
Oh, I see.
It's just
Wait,
really
is it-
annoying.
Is it in quantitative procedures or statistics?
Quantitative inferential procedures.
Okay. I like the first test better when there's all just like bubble in the answers.
No kidding.
Now they're making us do math. I'm like, all companies just use systems nowadays.
It's true.
Like what? I guess it's good to stretch you.
We need to put the socks in as well as a different variable.
I think so. Let's see. Let's see what
Yeah,
the question actually calls for.
'cause that's the 6th group.
Oh shoot! Dang it. That's-
Hey, so you guys are all online students or day students?
I'm online only.
Okay.
Technically in class, but I'm only taking online classes right now.
Are you gonna do IBC?
No?
I don't have to.
Yeah, I'm software engineering major.
Oh. Oh, this is crazy. I
You're
forgot.
business, aren't you, Brock?
Yeah, I'm finance.
I'm business as well.
We don't have to do IBC if we're in finance.
What?
I don't think we have to do IBC if we're in finance.
Don't play me right now. Are you serious?
Are you in IBC?
Where are you getting this information from?
Well, because you can't do IBC over the internet, can you?
Oh, I'm a day student.
Well, I know, but I can finish my degree online, and I'm pretty sure I don't have to do IBC.
Could you just make a website?
I'm just gonna change to software engineering.
Don't do it.
Just kidding.
All right. So question 8's asking for the smallest variance. Is that right?
What is the minimum variance? Yeah.
So hopefully we all put in the same thing. I got variable 3, 27.208.
Yeah, that's what I got too.
Okay.
Wait, where did you?
That is in the ANOVA test. So you look over at descriptive statistics, and it's got all the variables, and it has the variance in like the K column. And so we're just looking for the smallest variance.
I don't see that.
It's in the descriptive statistics to the right.
Are you in? Did you paste all your data in the ANOVA tab in quantitative inference procedures?
Yes.
So over to the right, you should have variables 1 through 6, and then the mean, standard deviation, variance, and n.
Yeah.
And so the variance for variable 3 should be 27.208. At least that's what I have.
That's what I got.
Me too.
Are you seeing that, Lauren?
No.
How many variables what's your n? Does it say 20?
Yes.
That's weird.
Wait, what is it? What does your third one say?
29.45.
What?
What does variable 4 say?
32.
Whoa.
That is very different from what I have.
Did
Are
you
they
paste
all-
it right?
Are they all from 6 to 25 equally, like all your numbers?
What do you mean?
From row 6 to 25, do they all line up?
In columns A through F.
Yeah.
So A6, you have 35,
Yes.
and A25 is 33.
Yep. No. It's 32.
Ooh.
Huh?
I don't even have a 32 around there.
Mm-mm.
Uh-uh.
B6 is 30. And B25 should be 28. You may have to repaste the data in there.
B6 is 27 for me.
It's all.
B7 is 27.
Uh-huh.
Yeah, I'm double checking and it's the same on my soccer shoes document.
That's weird. Let me check.
Yeah, I'm doing the same thing, making sure that I didn't add an extra one or something.
Oh, did you guys on I think it was one of the last tests or the homework, did you guys email the professor about those ones that we got wrong that we didn't think should have been?
Yeah, he told me that I got it wrong because I did the math wrong.
Yo, I got it right though.
Yeah, I did.
I copied him. I showed him like a screenshot of how we set up the Excel thing, and I was like, "Can you tell us what we did wrong?" And he's like, "You didn't do anything wrong. I'll change your grade." So
Yeah, I don't think he knew which questions I was talking about because I didn't do that because it wouldn't show up when I emailed him.
hmm
Yeah, I don't know. I'm still not getting that number.
Okay, well, we three have it, so we'll
Yeah.
just go ahead. So question 8 should be 27.208. And then question 9 should be 53.158.
Okie dokie.
All right, so are the test variances equal for these data? So they are considered equal if the largest one is less than 4 times the smallest. So I would say yes.
Yes.
Wait, why was that yes?
Because so if you look in the book at section 3.3 under the Excel instructions, it says if the largest variance is not 4 times as big as the smallest variance, we will conclude that the population variances are close enough that we can assume that the variances are all equal.
Oh, it's lit. Okay.
Oh, this is going to be so annoying.
QQ plots.
Yeah.
So which ones do we paste?
We have to do one at a time for each variable.
Let's split it up.
Yeah, I'll do 1 and 2.
I'll do 3.
I don't know if me doing one of them is gonna.
I agree.
I don't know what's going on though. Like I don't know why mine would be any different.
Well, I just pasted in the first one, and it is not normal.
Oh, really?
Yep.
So
I can
then,
do 5 and 6 then.
well, if that one's not normal, then we're good, yeah?
I would think so. But I'm going to double check just in case.
Whoa.
Because they're considered normal if they're in a straight line, right?
Yeah.
I think so.
Yeah, okay. So I would say no.
5's not even close.
Yeah, none of these are. Oh, wait. Hold on. Paste data in column A, and then sort column A from lowest to highest number. So I didn't try sorting anything. I don't know if that does anything different.
Yeah, that might affect it.
Oh. I mean, mine's kind of in a straight line.
Mm,
I don't know what the breakoff point is.
I would think that that's... Alright, so I'm going to go back and try the first couple. That,
Number 3 is normal.
Yep.
But when you sort it,
Yeah, it's all and you sort it. It looks like.
Yeah, 5 and 6 are pretty normal.
Hold on. Largest. Yeah, it looks like they are all normal.
So do they just have to be close to that red line, or?
Yeah, they just have to be more or less like close to that line. And that follows, I mean, we said the variances are normal, so I think, yeah, they're approximately normal for 11.
Okay. So
So,
11's true, right?
yeah.
Yeah.
Okay, so the p-value is 0.081, and we need to remove the SOX data and perform the test again. What's the p-value when we remove the SOX data? So SOX data is variable 6. We delete that, and it's 0.309.
Yes, that's what I got.
Wait, 11 was true then?
Yes, yep.
Okay. Alright.
The test statistic for an ANOVA hypothesis is an F statistic. It's to the right.
wait, why is it to the right?
Because for an F statistic, it's a right-tailed thing. And so it says it's always right skewed, the values are negative, never negative, and the p-value is the area in the right tail. We never divide the area in the tail.
So it's always right then.
Always right for an ANOVA test.
Alright.
Now we get to paste a whole lot of numbers again.
Yeah.
Oh, wait, what do we want?
We gotta do it twice too, don't we?
That's what I'm looking at. Okay, examine the calories first. And construct QQ plots of the calories for each of the 3 types of hot dogs.
So QQ.
Beef, meat, and poultry. I've never even heard of a chicken hot dog. Is that a real?
Yeah, those are real things.
Wow. That's amazing.
So how do we post these into this QQ plot then?
All right, so we have to do it one at a time. And so
I'll
you
do
paste.
the poultry.
What's the first? I did the beef,
Oh, I'll do the meat.
and it's approximately normal.
They're already. Yeah. Oh, never mind. Okay, yeah. Mine's pretty normal.
How do you sort them?
So you have to, when you go in there,
Sort and filter.
yeah. So highlight column A, go to Data, the Data tab up above, and click on Filter,
Got it.
and then sort it from smallest to largest.
Nice.
So let's see, the requirements. Requirements of the ANOVA test are that it's approximately normal.
Number the meat one is not normal.
And that the
Yeah,
variance
it's not
is
looking normal.
okay. Let's see.
We have to do this for both calories and sodium?
Well, for the first question, I think it's just for calories.
Okay.
So meat's not normal.
Right.
Is
So
that 'cause
make
that big gap in the middle?
Actually, make sure that you delete out all the stuff first, because I think there's less than the previous one.
Yeah, I did that.
Okay.
So it's not normal because of that gap in between, like the 0.4
Mhm.
and 0.7 ish.
Yeah.
Yeah, I think so.
Okay.
Well, it would be D then, right? That's the only one that really makes sense.
I think it's D.
Oh.
Yeah.
Yeah.
Now we got to do an ANOVA test.
Yep.
This is just for the calories, right?
I think it's just for calories.
You guys have less numbers for
The meat.
meat and poultry?
Yeah.
Okay.
All right. See, there's that probability of 0.000.
I just read that. Oh my gosh. Oh, that's ridiculous.
Would 15 be D also?
I think so.
Because
Yeah.
1 and 2 are pretty close, but 3 is pretty far off.
Yeah. That's what I was thinking.
So
Oh.
D.
Yeah.
Yeah. I mean, they're all different mean numbers, but I mean, they're close. The first two are close.
At least we can tell we're doing it right because all the other numbers line up.
Yeah. And I got the same numbers as
Everybody
everyone
else?
else, I'm assuming, so.
So at least your hot dogs are right, but your soccer shoes not so much, huh?
Those darn soccer shoes, man.
All right. So now we got to do for sodium. This is super fun.
So much. I'll do the meat again for this one.
All right, I'll do beef.
Meat. I think meat is pretty normal.
Poultry is not.
Beef, I don't know, like it's got some off the line, but it's all generally sloping up and to the right.
Yeah, that's how meat is too. But I think that we count that as normal, right?
I think so, because it doesn't have to be perfectly on the line. It's just generally up and to the right.
Mm-hmm.
What about poultry then?
Let me try the poultry and see what it looks like.
Poultry has a pretty big gap.
I don't think so for that one.
Poultry is not normal.
Yeah, poultry's not. I think it's C for 16. Because we can assume that the variances are equal because they're so close.
Yeah, that sounds about right.
I'm committed.
Well, and here's question 17. Despite the possible problem for the QQ plot for poultry, what is the p-value for this test?
So we got to go back and put that in the other.
No, I think, oh yeah, for sodium, that's right.
Yep.
What is the real world application of an ANOVA?
If we had to look at a ton of different variables, I guess.
Yeah.
Dude.
.179.
What's that I got?
Oh, I'm not there yet.
Sorry.
Oh.
Yep, 0.179.
Yee.
So for 18, it's C, right? Because they're so different.
I don't know.
Is there like a range? Is there like a range that it like has to be out of?
I think, I mean, the mean are so close. In the book, oh, that's for variance, I guess. The variances are equal if it's not more than 4 times the smallest, which it's not for this.
Oh.
I would say that means are pretty darn close.
Okie dokie.
Even for variable 3?
Oh, that's right.
Well, would it be D then?
Yeah. If variable 3 is the only one that's different.
Yeah, I just don't know how, like, what percentage the number would be.
And I'm not seeing it in the book.
I'm not either.
The question that asks something similar, the solution for it is just the answer. It doesn't actually tell you how to do it.
Sounds like an online class.
Yep.
I don't know. I think I'm gonna go with D, but
Yeah.
Alright, I'll submit first. Boom. Because I cheated last week. Okay. Oh! B, 18 is B, and 14 is A. Oh.
What?
there's
Why?
It's okay. I got instant karma.
14 was A, huh?
Yep.
I wish there was more explanation on that part.
Yeah. Well, thanks, guys.
Yeah.
See you guys on Thursday, and get ready for the test.
All right, sounds good.
All right. See you
See ya.
guys.
All right, see you. Thanks.
Yeah.